Well, good morning and welcome to Space Oddities. Thank you for joining us on this Tuesday morning for the launch of the European Proba-3 mission. Such an interesting mission. If you were watching yesterday, you'll know that the mission was cancelled just with a few minutes to go because of an anomaly in the spacecraft. But today it looks as if everything is going ahead at the moment. We're anticipating a launch in about 25 minutes from India. But before we do that, in case you're not familiar with what the Proba-3 mission is, as if you weren't here yesterday, I'm going to show you a video from the European Space Agency about that. But obviously, I'd like to welcome Daz and Roger here this morning. And I hope you're all well. Yeah, you're all right?
Yes. We're all lovely, thank you. All lovely.
Michael's just, what's the word? Wafted in.
Yeah.
So how are you, Michael?
Fine, thank you. I've just dissolved in.
Yeah, it looks like he's in the future. We've got starships everywhere.
Yeah, absolutely. Yeah. Okay, so anyway, just about a 9-minute video. This is all about the Proba-3 mission. It's a really interesting mission, so we hope you enjoy this.
Total solar eclipses. A spectacular celestial event where the moon precisely covers the sun, unveiling the sun's corona, the outer atmosphere extending millions of kilometres into space, or what you may know as the sun's rays. This phenomenon is very rare, only occurring approximately every 18 months and only in certain regions. For millennia, scientists and enthusiasts have chased eclipses using the precious few moments that the sun's bright surface is covered, to try and gather as much information as possible about this elusive outer region of the sun. Understanding the sun's outer atmosphere, or corona, is crucial for understanding how the sun works and how it gives rise to space weather. But what if we could make solar eclipses on demand? It is not impossible to see the sun's corona without an eclipse. Scientists came up with a device called a coronagraph that is able to block out a star's brightness and see surrounding features. A coronagraph works like holding your thumb up to block the bright sun, so you can see the faint halo of light around it. Imagine you're standing outside on a sunny day and the sun is so bright that it's hard to see anything around it. If you hold your thumb up at arm's length to cover the sun, you block its intense light, allowing your eyes to see dimmer details like a faint aircraft or clouds nearby. A coronagraph on a telescope works in the same way by blocking out the sun's brilliant disk with a small mask inside the telescope, allowing scientists to see the faint structures of the sun's outer atmosphere, the corona. The corona has left scientists baffled for many years. It has several characteristics which should not make sense in physics. We spoke with our system engineer, Esther Batista, to help us understand more about the corona and its mysteries.
The corona of the sun would be the outer part of the sun's atmosphere, and right now this is a region of the sun that has been very poorly investigated, and so scientists nowadays don't really understand some of the phenomenon that's happening there. And one of the things that we really want to understand is why is that way hotter than the sun itself, or how do coronal mass ejections or solar wind originate in this area?
While the sun's surface, the photosphere, has a temperature of about 5,500 degrees, the corona is much hotter, reaching temperatures of 1 to 3 million degrees Celsius. This challenges our understanding of how energy is transferred from the sun. Scientists have called the phenomenon the coronal heating problem. The corona is also the source of solar wind, a stream of charged particles that travels through the solar system, and coronal mass ejections, huge eruptions of solar material. By studying the sun's corona, we can better predict space weather and extreme geomagnetic storms, which can cause major disruptions to satellites and systems on Earth. We already have instruments that can study the sun, but between the low corona and the high corona, there is a region, a gap, where observations are difficult to make. Normally, it's only possible to observe this region during a solar eclipse. However, using Proba-3 will be able to create eclipses on demand. Compared to a total eclipse, which happens very rarely at any given location on Earth, you might only experience a total solar eclipse once every 375 years and typically lasts just a few minutes. Proba-3 will be able to study the corona for 6 hours in every 19-hour, 36-minute orbit. Proba-3 consists of 2 satellites which will work together to produce the solar eclipse, or coronagraph effect in space. The satellites will be able to maneuver themselves to line up with the Sun. One spacecraft will cast a shadow onto another to produce the solar eclipse effect. If the two are not perfectly aligned, then the bright disk of the Sun will not be hidden by the instrument, and the corona will be obscured by its bright light. The sunward side of the mask satellite also hosts a dedicated instrument that will maintain a continuous measurement of the Sun's total energy output, known as the solar irradiance, which is an essential measurement for climate studies. A standard low Earth orbit was quickly ruled out for Proba-3 because of all the influences that would affect the pair, the stronger pull of gravity, plus changes due to Earth's imperfect shape, and air drag up from the top of Earth's atmosphere, along with Earth's reflected light.
Proba-3 has a highly elliptical orbit, which means that between the point closest to the Earth and the point farthest from the Earth, there is a big difference. In our case, we have a 19-hour orbit, and the closest point to the Earth is 600 kilometers, and the farthest point from the Earth is 60,000.
Picture it as a roller coaster loop-the-loop. Around the bottom of the orbit, the spacecraft move much faster, but slow down as they climb higher, and because of this decreased velocity, spend more time at the apogee of the orbit than at the bottom. For the lower part of the orbit, the pair fly freely, although ready to react if a collision risk emerges. Then, as they move up towards apogee, the signal is given for them to begin moving into active formation, which takes about 2 hours.
In our case, the path that is followed by the spacecraft will be altered over time by different perturbations, such as the Sun and the Moon perturbations. And what will happen is that the path followed by the satellites will be slightly changed every year, and 5 years after the life of the mission, the spacecraft will re-enter naturally the atmosphere of the Earth and burn in the atmosphere. Therefore, we will not leave any space debris after Proba-3.
Although the concept of a coronagraph may be relatively easy, flying 2 spacecraft in perfect alignment is extremely difficult. Proba-3 is the first ever precision formation flying mission, meaning that we are sending 2 satellites which will sit at about 150 meters apart in space, roughly 1.5 football pitches, but will be able to fly together with exceptional precision. The satellites are placed at this distance to prevent the spillover of stray light, known as diffraction, over the edge of the coronagraph, and making it hard to observe the Sun's inner corona. Diffraction increases when the satellites are closer together. For Proba-3, observing distance will be greater than any other coronagraph so far, reducing the diffraction effect as much as possible and giving us the clearest possible view of the corona. Additionally, when objects in space get as close as Proba-3's satellite will, they are at risk of collision. If anything were to go wrong, everything happens too fast for human control, so the pair must be able to fly themselves in formation. The 2 satellites will use radio links, cameras and reflected lasers to sense where they are relative to each other. Their positions will be controlled down to 1 millimetre precision to prevent any disastrous slips. The mission is expected to last 2 years. Afterwards, the orbit on which the satellites are flying will slowly decay due to gravitational perturbations from the Sun and the Moon, which will cause the satellite to naturally re-enter into the atmosphere. Proba-3 will help us unlock some of the mysteries of the corona, not only to improve our understanding of the Sun, but also the origin of solar weather, such as coronal mass ejections or solar storms, which can affect the functioning of satellites or communication and power networks down here on Earth. It will also allow us to fly all kinds of future missions in perfect formation to create giant virtual spacecraft, like giant telescopes or arrays that would be impossible to fly any other way.
Okay, so there we are. So that's a brief look at what the mission's all about. Very interesting mission. Any comments about that, guys?
It's very interesting concept.
Yeah, it's a well. This is the first time I think ESA have actually tried to fly anything in formation with such precision. So for them, this is sort of like a proof of concept as well as to do science as well. Because I think I discussed yesterday, Proba is not the actual satellite itself. Proba is the actual bus, as they call it. It's the framework of the satellite, and the idea is it's off the shelf. You buy off the shelf a satellite frame, like a skeleton, and then you put your instruments design and put your instruments into this little bus, because these are only mini satellites. They're not massive satellites. And so, as I said, you go along to your local DIY shop, you choose your satellite, better framework, and then you put your instruments inside. So there have been previous, because of course we're calling this Proba-3, but this is actually number 4. The first Proba, which was more of a test flight, but it did have some instruments on it, which were Earth observation instruments, was launched in 2000 and what was it, 2004 or 2000?
So,
2001. Sorry,
oh,
it was
right.
launched in 2001. It was supposed to last 2 years. They're actually decommissioning it next year on its 25 years. So it's obviously a robust little satellite. There was also then Proba-2, which was again a sun observation satellite. Then there was Proba V. Now that didn't stand for 5; it stood for vegetation. Again, that was an Earth monitoring satellite, and that was launched 2000. Let me just have a look. I've got it here somewhere.
Well, a few years ago, anyway.
Yeah, it was a few years ago. I think it was 2018 or 19 or something like that. So they have been working away. And then, of course, now we've got Proba 3. And this again, as it was said, it's going to be a coronagraph system with 2 satellites flying together. So, yeah, they're a happy little family. And what I do like about it also is that they've also planned in the end of mission return to it returns through the atmosphere of the actual satellite, so there'll be no more debris.
Sure.
Of course, now this is one of the things that everyone's got to plan into their missions now. They've no, let me get this right. There were 3 options, wasn't there? You could either push it up into a graveyard orbit, or you could. There was one you could either return it through Earth, the Earth's atmosphere, so it'll burn up, and I think the other one was actually put it into a sun synchronous orbit, so you send it right out into the middle of nowhere. So yeah, but this is a really interesting project with the Coronasphere flying 2 spacecraft synchronized, so you get that perfect total eclipse all the time.
And they have to be synchronized to within the width of a human thumbnail, otherwise they don't get the the correct eclipse.
That's right. I mean, they are. I think she said 150 meters apart. But as Andy said, they've got to be that precise, so you get the corona. And of course, I'm a bit of a sun nut, so this is a project that's close to my heart to study the corona.
Yeah.
So it's absolutely fantastic. It's a fascinating little machine.
So let's have a look at what's going on at the launch site in India. And nothing much at the moment. I'm sure we get a glimpse of the rocket in just a moment. But
is it
conversing in Indian? So we'll leave the sound off for a moment. Not that there's anything wrong in conversing in Indian, of course, but we don't understand what they're saying, so we can't tell you what's really going on. There we are.
Nice,
and there is
rocket.
The Indian launcher. I notice there's no sign of any venting going on there. Is this
I don't know what the fuel is. I mean, everything should be cold anyway.
Yes, absolutely. I see they've got 4 SRBs there, solid rockets.
Yeah, solid rockets. So you can expect this to disappear off the pad like grease lightning.
Absolutely. Absolutely. Yes. We're so used to seeing
this is
liquid fueled rockets like the Falcon.
As you know, we all love a good launch.
Yeah.
We're so used to seeing liquid fueled rockets sort of pondering whether they should actually leave the pad or not, and then deciding, oh, go on, let's go. But this will be a rapid launch. In fact, they've got more than 4 there, haven't they?
Yeah, they got 5. Yeah.
Yeah. So 5 solid fuel rocket boosters to give it that extra oomph to get it off the pad and on its way. So we're looking now at a launch. If everything goes to plan, they haven't got a countdown up on the screen, but if everything goes to the schedule, they should be launching in about 16 minutes. Oh no, less than that. No. About 14 or 15 minutes. They should be launching. So at the moment, it's all systems go in India, and we're eagerly awaiting this mission. Now, some of you might wonder why Europe is launching on an Indian rocket. And Michael, I think you've been looking into this.
Yeah, I have. I just wanted to say an update on the launch time. The latest launch time I've got is 10:34 our time.
Oh, so slightly sooner, because they were saying 10:42.
Oh, that's on, and I'll just check on the other site as well.
Right.
They just showed a countdown clock. What was that for? That said 1 minute something or other.
I don't know.
It's still in 11:34 CET on the European Space Agency site. So
right.
That chap had a big yawn.
Could be any minute now.
I see one bloke's really excited. He was yawning his head off.
Well, let's put some sound on.
You're talking about me again?
-1 minute.
सर
हम ठीक 1 मिनट दूरी पर
-55
सेकंड से
Wow. Here we go.
सभी गतिविधियां आबाद रूप से जारी
-50 seconds.
सीक्वेंस ऑफ सेकंड्स पर रिएक्शन कंट्रोल थ्रस्टर को प्रज्वलित किया जाएगा फिर T0 पर कोर बूस्टर प्रज्वलित होगा
-40 seconds. -35 seconds.
Fingers crossed time.
Yeah.
Fingers and legs crossed.
Go Proba-3.
seconds.
Real time programs activated.
-25 seconds. -20 seconds. I like the clock.
Lovely.
-15 seconds.
Spent a lot of money on that.
Yeah. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
Wow.
Liftoff normal.
Majestic liftoff of the PSLV C-59 Proba-3 mission from the Satish Dhawan Space Center.
जी हाँ PSLV C-59 प्रमोशन यान का सफलतापूर्ण उत्थापन रेंज ऑपरेशन डायरेक्टर ने भी इसकी पुष्टि कर दी है यह पूरी तरह सामान्य उत्थापन है और अपने उद्देश्य की रक्षा की ओर बढ़ता हुआ PSLV C-59
The core for S-139 stage, thrusting along with the solid strap-on motors.
Yeah, very good one.
That launch went off very quickly.
Yeah.
प्रथम चरण का प्रज्वलन जारी है। यह लगभग 109 सेकेंड्स तक चलेगा। इस दौरान कुल 9000 किलो न्यूटन का प्रणोद उत्पन्न करता हुआ प्रथम चरण यान को उद्दिष्ट दिशा की ओर ले जाता हुआ।
First stage performance normal.
We are 58 seconds into the launch.
Well, it's normal, not nominal.
Burning together. The first stage,
Start to man at
the
a
core motor and the strap-ons together generate about 9,000 kilonewton
Star 1 man
thrust.
at a tracking.
इस क्रम में
First stage performance normal.
अब हम आगे देखेंगे ग्राउंड लेड
Don't know if you
स्ट्रैप-ऑन का
noticed, we
पृथक्करण,
just
तत्पश्चात
few of the boosters
एयर
have
लेड
just
स्ट्रैप-ऑन को पृथक किया जाएगा और अंत में प्रथम चरण के कार्यकाल के पश्चात उसे भी यान से पृथक किया जाएगा।
The Shard telemetry and tracking station presently acquiring the trajectory data. There is a confirmation about the strap-on separation.
Second stage engine started. Closed loop guidance initiated.
प्रथम चरण को यान से सफलतापूर्वक पृथक कर दिया गया है और द्वितीय चरण का प्रज्वलन शुरू हो चुका है।
Confirmation has been given by the Range Operations Director. The second stage of PSLV has begun its operation.
Great.
The closed loop guidance having been initiated, hereafter the trajectory steers, implementing necessary corrections to achieve the final insertion point of the spacecraft.
Well, there we are, guys. A fantastic launch.
Yes.
yeah,
So far,
certainly
so
was.
good.
यहाँ आप ग्राफ में देख सकते हैं यान पूरी तरह अपेक्षित पथ का अनुकरण करता हुआ जा रहा है। सभी तंत्र सामान्य रूप से कार्य करते हुए।
The pump-fed Vikas
I
engine
just wish they'd
operating on
take a leaf out of
hypercolic propellant
SpaceX's
combination of
cameras on the
UH-25
rocket.
and N2O4,
Yeah.
generating
Having
close
this,
to 800 kilonewtons
the
thrust.
famous animations.
Yeah.
Plus 3 minutes.
जी हाँ, द्वितीय चरण का कार्यकाल लगभग 152 सेकंड का होगा। इस चरण में UDMH और N2O4 का इस्तेमाल होता है और अब यान
By the way,
से
that
ऊष्मा
graph on
कवच
the
को
right
पृथक
is
कर
not
दिया गया है।
indicating altitude. Otherwise, they do have.
यह यान अब घने वातावरण से बाहर जा चुका है, इसलिए अब ऊष्मा कवच की कोई आवश्यकता नहीं है, इसलिए यान से पृथक किया जा चुका है।
With the payload fairing separation, the rocket has left behind some more
Second stage
unnecessary mass.
performance
Dense
normal.
atmosphere is crossed now. No more requirement to shield the spacecraft or the aerodynamic shape. Char and Port Blair stations currently tracking.
सभी गतिविधियां पूर्व निर्धारित तरीके से जारी हैं।
Yeah, it's a shame we
हम
got no
प्रमोशन से
images.
230 सेकंड की दूरी पर आ चुके हैं। इस समय ऊंचाई 147 किलोमीटर तथा सापेक्ष गति 4.2 किलोमीटर प्रति सेकंड।
152 kilometers altitude. We are 247 seconds into the launch. PS2 still operating.
द्वितीय चरण के दौरान
The fairings
यान
away.
क्लोज लूप गाइडेंस के अंतर्गत होता है, यानी वह अपना
There we
दिशा
see in
निर्धारण
the
स्वतः ही
animation
कर रहा है।
the two Proba-3.
Second stage separated. Third stage ignited.
और यहाँ द्वितीय चरण अपना कार्यकाल सफलतापूर्वक समाप्त कर यान से पृथक किया जा चुका है तथा तृतीय चरण जो कि ठोस नोदक पर आधारित चरण है, उसका प्रज्वलन शुरू हो चुका
Third
है।
stage performance normal.
तृतीय चरण का निष्पादन पूरी तरह सामान्य। यान अपने उद्दिष्ट कक्षा की ओर बढ़ता हुआ उद्दिष्ट पथ पर।
Third stage of PSLV, called HPS3. Ignition is confirmed and
So
the
ESA
operation also
officials
is
there looking very
confirmed by
happy,
the
obviously.
Operations Director.
Mhm.
The stage operates on hydroxyl terminated polybutadiene
He's
based
the
solid propellant.
delegation.
7.6
Well, this is a great
7.6 tons of
example of
propellant loading,
international cooperation, isn't it?
239.6
Yeah.
kilonewtons vacuum thrust.
The guy on the tannoy sounds like Sid from UFO.
यूरोपियन स्पेस एजेंसी से आए हुए गणमान्य व्यक्ति यहाँ उपस्थित
Third stage performance
इस
normal.
प्रमोशन मिशन के साक्षी बन रहे हैं.
I was going to say that like he sounded like an announcer in Blofeld's lair in James Bond.
तृतीय
Oh,
चरण
yeah.
का कार्यकाल
Oh,
लगभग
yes,
120
that's
सेकंड
right,
का
yeah.
होगा. तत्पश्चात कोस्ट फेज प्रारंभ होगा.
And you only live twice. It was Bert
Like-
Cook, wasn't it, who was doing the announcements? Astronauts to the launch
PS3,
pad.
the operation time is 120 seconds.
Like astronauts to the launch site.
As we informed you earlier, significant increase in relative velocity takes place during the PS3 thrust regime.
यह उड़ान दक्षिण पूर्वी दिशा
Okay,
की
we,
दिशा
we,
की
we
है.
don't know what actual
इस दौरान
the two
पोर्ट ब्लेयर
satellites are going to
स्थित रडार
separate,
स्टेशन
but
वर्तमान में इसे
everything
ट्रैक
will
कर
be
रहे
wrong.
हैं और हम
Looks
तक
almost like
भी
it's
आपको
going
उपलब्ध
into
करा
a
रहे हैं.
polar orbit at
Yeah.
that angle.
Yeah.
तृतीय
Engine
चरण का
program.
कार्यकाल
Combined goes
समाप्त हो चुका
for
है
a period of 105 seconds approximately.
और
Yeah.
कोस्ट फेज प्रारंभ हो चुका है. यह लगभग 116 सेकंड का होगा. इस दौरान यान प्राप्त संवेग से लगभग 100 किलोमीटर प्राप्त करेगा.
Okay.
Now the PSLV is under coasting phase. The third stage has completed its operation. Presently there is no thrust being developed. However, the vehicle continues to be steered.
Okay, so looking at that graph, it looks like we've got some time before separation or deployment, should I say?
Yeah.
यान पूरी तरह अपेक्षित पथ का अनुकरण करते हुए इसे हम टेक्स्ट बुक लॉन्च भी कहते
Peaking
हैं.
performance normal.
PS3 separation is scheduled at 489.2 seconds into
I
flight.
should have said that. Get it out of my head.
We are 450 seconds into the launch.
It's amazing how far India has
प्रोबा-3
come.
उपग्रह अपनी कड़ी में
in
चौथा
the
अध्याय
space
जोड़ने जा रहा है.
program.
इससे पहले
Yeah,
प्रोबा-1
sure.
को 2001 में पृथ्वी के प्रेक्षण उपग्रह के रूप में प्रमोचित किया गया था, जो कि 20 साल से अपनी सुविधाएं प्रदान कर रहा है. उसके बाद प्रोबा-2 का प्रक्षेपण 2009 में सूर्य का प्रेक्षण करने के लिए किया गया. तत्पश्चात प्रोबा-V
Third stage separated.
There we are.
अभी रेंज ऑपरेशन डायरेक्टर ने पुष्टि की
And there's
कि
the actual
तृतीय चरण
Proba-3
को
path.
भी यान से पृथक कर दिया गया है. अब इसके 10 सेकंड के पश्चात
Fourth stage engine started.
जी हाँ, चतुर्थ चरण का प्रज्वलन भी शुरू हो चुका है.
The fourth stage has commenced its operation. It's the uppermost stage. Twin pressure-fed
stage
engines
performance
operating on
normal.
Earth-storable propellant combination of monomethyl hydrazine and mixed oxides of nitrogen.
दर्शकों, आपने गणतंत्र दिवस की परेड तो देखी ही होगी और उसमें फाइटर जेट एरोप्लेन के विभिन्न गठन उड़ाने, जिसे हम फॉर्मेशन फ्लाइंग कहते हैं, कितना आश्चर्य और रोमहर्षित करने वाला होता है. कितनी सटीकता और एकाग्रता की आवश्यकता होती है. बिल्कुल वही दृश्य आज हम अंतरिक्ष में पृथ्वी की कक्षा में देखने जा रहे हैं. यूरोपियन स्पेस एजेंसी द्वारा तैयार किया गया प्रोबा-3 एक अनूठा मिशन है जो यह फॉर्मेशन की तकनीकी तथा तकनीक दोनों का प्रदर्शन करने जा रहा है.
Do you see the guy
इस
asleep?
मिशन में 2 उपग्रह हैं जो
Don't be
प्रमोचन
surprised.
यान से पृथक होने के पश्चात आपस में एक निश्चित दूरी बनाए रखते हुए
Look,
600 बाई 60,530 किलोमीटर की दीर्घ
Fourth
वृत्ताकार
stage
कक्षा में
performance normal.
full stage performance.
पृथ्वी की परिक्रमा करेंगे. यह पहली बार है जब एक ऑकल्टर और एक कोरोनाग्राफ उपग्रह फॉर्मेशन बनाने जा रहे हैं. यह आगे आने वाले बहु उपग्रह मिशनों में गठन उड़ान का मार्गदर्शन भी कर सकता है. इस फॉर्मेशन में दोनों उपग्रहों के बीच लगभग 144 मीटर की दूरी होगी और इसे मिलीमीटर की सटीकता के साथ 6 घंटे तक के लिए उस फॉर्मेशन में बनाए रखा जा सकता है.
Okay.
इसमें आश्चर्य की बात यह है कि यह फॉर्मेशन, ये उपग्रह आपस में सामंजस्य.
As we can't understand what they're saying at the moment, let's just cut the sound on that. So, a successful launch, guys.
It certainly was. I mean, you mentioned cooperation, and of course, you were talking about between ESA, and the Indian launch provider, but actually the whole of the Proba initiative, it actually involves 15. Let me just find where it was. It's 15 companies and institutes from 5 European member states.
Wow.
So there's even more cooperation here.
Yeah.
I thought I did have a list of them actually somewhere, but can't find it here. But yeah, so there was 5 European states involved and spread out between 15 companies.
Yeah.
So yeah, it is a collaboration all the way round.
Absolutely.
So yeah, that was a fantastic launch. I don't know if you noticed, we were counting the boosters, and we saw 5. But when we got a close up, did you notice that there was 2 small ones that actually fired before the bigger
Yeah, I
one?
noticed that. Yeah.
And we actually saw those 2 small ones fall away from the vehicle once they were spent. We didn't get a chance to see the big ones because they were still firing, of course, because they had more fuel in them. But yeah, we saw the 2 small ones fall away. So they just needed, obviously, those 2 little ones just to give it that, just that little bit more. But yeah, because we couldn't see them at first. But when we had the close up, because yeah, that was a fantastic launch. It's a shame, like you say, we didn't have more live images, but say la vie, it is what it is.
Well, that's what...
Because wasn't this isn't their normal launch site, is it? Did somebody say?
I don't know.
I thought
Anybody
somebody
shed
said.
light on that? Is this a normal launch site?
Oh, I don't know. I could be wrong.
I think it is. You know.
Yeah. Yeah, I thought it was. It looked familiar anyway.
Yeah, I've heard the name Satish Jawan before.
I probably misheard something. It looks like a bit of a bumpy ride, to be quite honest. Look at that. Yeah, sort of like a bit of a roller coaster.
Yeah.
But,
so you can see there the top right. Oh, it's gone. The top right of that graphic, the satellite separation. So it's coming up in a few minutes. So I suggest we hang around, guys, until the separation's confirmed, and then call it a day. It's amazing to think it's already travelled 3,700 kilometers downrange.
Yeah.
I mean, that's fast.
That is quick.
Yeah. I mean, that's what you get once you strap on these solid boosters. They just absolutely, they're gone.
Yeah.
Yeah.
You know, once they fire those, because of course, solid boosters you can't control. Once they're lit, they're lit.
Yeah.
So if you light them and then something happens, you've still got to let the rocket go because it's going to go, because you can't shut them down.
No.
There's no thrust control or attitude control with them.
No.
So yeah, well, but they literally, every time you see one of these rockets with the boosters on them, they just literally, they're just off the launch pad like nobody's business. They really are fast.
Yeah.
So
indeed. Well, while we're waiting for satellite separation, just a reminder that we will be back next Tuesday, inevitably, for our Tuesday live stream. Not quite sure what we've got coming up for you next Tuesday, but we will have something. So that starts at 8 p.m. UK time next Tuesday on the Space Oddities YouTube channel. Don't forget, we have our new Space Oddities website, which has just gone live or recently gone live, on which you'll find all sorts of useful stuff. And just give me 1 second and I will put a link to that up on the screen. Go and have a look, tell us what you think, and you can contact us at any time if you want to give us some feedback or anything. In fact, by sending an email to info@spaceoddities.space. That's info@spaceoddities.space. So we hope you enjoy the website, and also don't forget the Facebook group, which is Space Oddities Live. So you can join the Facebook community there for Space Oddities, and there we are. So the new website has the address of https spaceoddities.space. Simple as that. Very simple. Very easy to remember. We like it like that. So do go and have a look at our new website. Give us some feedback. Drop us an email at info@spaceoddities.space. and we'd love to hear from you. So there we are. On the 17th of December, Michael here, for his sins, is doing the Space Oddities Christmas quiz.
I am.
He's working on it. Is it going to be just astronomy or astronomy and sci-fi, Michael?
I think I'm gonna add a little sci-fi in it, I think.
Okay, so if you want to pit your wits against us and the other viewers, tune in on Tuesday the 17th of December at 8 p.m. UK time for the Space Oddities Christmas quiz. It promises to be a lot of fun. We normally have a lot of fun with our quizzes, so we hope you can join us for that. Coming up...
It won't be as long as the one I did at the Astronomical Society now.
Well, I'm sure. Coming up on the Tuesday, the 4th of February at 2 p.m. UK time, we have a very special event. We are putting together a project in association with SpaceX, where two astronauts, Anna Menon and Kate Gillis, who flew on the groundbreaking Polaris Dawn mission in September, will be speaking to UK schools live and answering the children's questions. So the idea of the event, which we're all very passionate about, is inspiring young minds and encouraging them to reach for the stars, as it were. So that's 2 p.m. UK on Tuesday, the 4th of February. Tune in and you can watch the event with Anna Guinness and Anna Menon and Kate Gillis, the two SpaceX astronauts answering questions from children in UK schools. We're very excited about this. And if it's successful, we hope to do similar events in the future. It's very, very important, obviously, to inspire young minds. So there we are. So some exciting times coming up on Space Oddities. Just a reminder that we won't be with you on the 2 Tuesdays over Christmas. Christmas Eve this year and New Year's Eve fall on a Tuesday. And that's when we normally do our live streams. But because it's Christmas Eve and New Year's Eve, nobody's likely to be watching. And we'll be occupied doing other things. So no Space Oddities on Christmas Eve or New Year's Eve this year. But we'll be back as ever in the new year with our regular Tuesday live streams. Do have a look at the other videos on our channel. We have approaching 400 videos on the Space Oddities YouTube channel. Everything to do with astronomy, astrophysics, cosmology, space exploration. You'll find an enormous amount of stuff there to watch. And again, if you have any feedback or suggestions for future videos or anything really, do drop us an email at info@spaceoddities.space. So there we are. So how long have we got now until the satellite separation? Do we think not long?
Ooh, we haven't got a clue.
Right, that graphic comes back up on the screen. Yeah. But these are nice graphics.
Yeah, very, very colourful.
Yeah.
Because we're going back to Proba-3. Oh, there it goes.
Oh, fantastic. There we are. We have it.
Yeah, we just made it.
We got some images.
Oh, yes. That's good.
Images.
They must be on the probe themselves then.
They are, yes.
Yeah. Look at that. We've actually got images from the satellites, which we did not expect.
Oh, that's good. That's fantastic.
Yeah.
Of course, we've spoken about the Coronagraph, which is on the actual satellite. But there are two other instruments which we'll be studying. There's one called DARA, which is the Digital Absolute Radiometer, which will maintain a continuous measurement of the sun's total energy output, known as the total solar irradiance. And there's also a 3D energetic electron spectrometer, which will measure the electron fluxes as it passes through Earth's radiation belts, providing data for space weather studies. So it's not just one trick pony. It's going to be doing several important jobs.
Absolutely.
So
and it's important
it all on that little satellite.
Yeah, it's important to emphasize as well, in case you're wondering, why do we need to study the sun in so much detail? Well, firstly, it's science, therefore it's really cool. But more importantly, we are very much at the mercy of space weather on the Earth. We know that we are approaching solar maximum as far as the sun goes in its 11-year cycle, and excessive activity on the sun in the form of flares and coronal mass ejections can cause havoc on the Earth and cause damage to satellites, disrupt power grids, disrupt radio communications, and all sorts of things. And we never know when these events are going to happen. So the more we know about the sun, the better we will be able to predict the activity that might be threatening to us on Earth. Of course, back in, we've talked on this channel before about the famous Carrington event. But if such a thing were to happen today, an event of that magnitude on the sun, it would severely disrupt our modern technological society. So the more we learn about the sun and its activity, the better chance we have of predicting when something bad's going to happen. Not that we can probably do much about it, but it's forewarned is forearmed, as they say. So we will look forward to seeing the results from Proba-3, and there we are. So I think we will draw things to a close for today. So we would like to thank you very, very much for watching. It's really good of you to spend your time with us this morning. And we hope you've enjoyed the coverage. And as I said, we'll be back on Tuesday with our normal live stream at 8 p.m. UK time. So any final thoughts, guys, before we tootle off into the sunset, as it were?
Well, it's going to be fantastic when this these two little spacecraft get themselves sorted out and we start getting data. Hopefully some of the data will be available to the public, so we'll be able to see some of the images and things like that. So yeah, looking forward to it.
And I'm sure some of that data will make its way eventually onto your Solar Watch spot on Space Oddities every Tuesday.
Hopefully, because I've got very little with unfortunate events that have happened in America.
Yes.
We've lost the best satellite. So yeah.
In case you don't know, every Tuesday Daz does a Solar Watch spot where he tells us all about what's going on the sun, which, as I said, is really important to know. So we look forward to seeing some of that data. So I'd like to thank Daz, obviously Roger. Thank you for being here. Michael, thank you for sharing this with me.
Thank you, everyone,
and
for
we'll see
being
you
here.
next Tuesday on Space Oddities. But in the meantime, don't forget, you've got hundreds of videos on our YouTube channel to watch, and we hope you enjoy them. Any feedback, suggestions, whatever, send them to info@spaceoddities.space. So from all of us here at Space Oddities,